overwhelmed by this particle because there's a contradiction going on. Every particle wants to fall to the center of the black hole, and every particle is working on doing that. But when two appear, and from its own point of view, these two particles are in the center of the black hole. Technically, you can break this down further, but I want to make it simple. So these two particles are in the center. This particle is in the center from its own point of view. But now the gravitational force of these two particles are greater than this one particle. So they may move a little bit, but this one's going to move a little faster and be overtaken, and they're going to accumulate. The three particles now are together, and they're all three bound, believing that they're falling to the center of the black hole. So when you have one mass that's a certain size that's heavier than another mass, you have a logical contradiction in the space particle, and the lighter one has to join up with the heavier one, and now they're all in the middle. And if that gets heavy enough, it'll actually crush in upon itself, creating a new dualistic corpuscular time shared space. It's a time reunitizer, a reality maker. Okay. Our time is what we know the best because we are in it. But our black hole that we came from is at a massively faster, this is talking about superposition, it's at a massively faster corpuscular time rate than ours, than here. But it is in sync with us, or it's superposition. Or it's superpositions. Well, anyway, it isn't. It's intimately connected with us. Its superpositions would not be predictable at all, and the interference pattern would look completely different if it wasn't in sync. So, yeah. There is a virtual space that acts like a buffer to this space, and there are several tests that could be done to prove it. In fact, they already have been done, many of them. And I was studying some different stuff I just wrote in here. Space for an individual particle. I got the particle number 1, 2, 3, and 4. They all basically look just like particles in the center of a space. 1, 2, 3. Let's see. I'm going to change here. So we got 1, 2, 3, 4. Each particle is a different particle in the center of the black hole. Same black hole. But this particle believes it's all alone in the center of the black hole, and it believes it's in the center. This particle believes it's all alone in the black hole, and it believes it's in the center. And this one believes it's in the center of the black hole and all alone, and this particle believes it's in the center all alone. But in reality, this is how it is arranged this is number one's point of view. From number one's point of view, it's right here, but from a point of view in space-time, you would see that particle here, the second particle could maybe be here, the third one there, and the fourth one there. But if you change that point of view from each one's perspective, that'll change accordingly. So each particle is in a different space, but from its own point of view, it is in the middle. From number one's point of view, and then I gave you the example, number one is in the middle. The reason I say that the redshift could be an optical effect is because when you notice that, let's see, if you have a particle that's in the center, and from its point of view you see another particle that's distant away, the only way that you can get away from the center of the black hole is through being pushed further away. And if you could go fast enough, you'd make it near the edge, but you'd have to be going light speed. So if you're near the edge, you will be going light speed even if you're not going light speed, because it's an optical effect. So it's like a contradiction. If you're on the particle near the edge that appears to be going light speed, then the particle back there that saw it going light speed would also look like it's going light speed in the opposite direction, because it's near the edge. It's a view. It's because of where it is. And if you put a piece anywhere in the universe,
the universe would look the same from any point, and that's been said before in almost, I mean, in a different way, but that was the truth, and this, I believe, is the truth. Let's see, the reason I say that the redshift could be an optical effect is because to push a particle out of the center of the black hole, you'd have to push it at x light speed. So all particles would appear to be traveling faster towards the edge of our space. There's somebody studying this right now. He's a physicist, and he says that it's ironic because it matches my model. He says for sure that and he's being ignored by a lot of science. So, but this model matches up with so much stuff. I would hate to think that science would ignore this because it would be not advantageous. They are all in the middle because space wraps around each particle at superposition speeds, a reunitized speed. In the black hole, mass and energy are separated. Energy goes north to south, mass goes from east to west, and both orbit in this regard as it is the intersection that creates particles if it's persistent. If it's a persistent cooperation. And also later on I talk about frames, so it works on frames of reference, which is all of this is an extended form of relativity. The relativity, Einstein's theory of special relativity, I like saying special relativity, it has a lot to do with special relativity, and everything else will fit because, so anyway, Einstein's theory of special relativity goes up to the event horizon. The event horizon is a line of separation, and a new system is formed inside of the black hole. That system is reunitized, so everything's changed, and it has to be judged according to that new unitization. Here, where we are, we have half of the unitization here, and in superposition is the other half of the unitization. If you look at superposition, it's what they call fuzzy, the wave function. It's all the same thing. Those are the same three things, and that is because it's out of phase from here. So if you create a coincidence, a cooperation, a matchup, not out of phase, then say like if you have a photon that's out of phase, you have a wave function. But if it goes in phase, then you get a photon. It's in focus. It's aligned. It's not a collapse of anything. Massless, I mean, we could still call it the collapse of the wave function, but it shows you a deeper meaning of what the collapse of the wave function is. It's in phase. The two corpuscular times become in phase, and a photon forms that we can see then. Let me see. Massless particles travel from north to south, spin up, spin down, and massless particles travel from east to west. Each particle is in a space of its own and becomes connected to the other particle involved. All particles can connect and become as if sharing the same space and yet seem separate in this reality. The masses and the potential mass rotate at different rates, orbits at different rates. And I crossed a bunch out. And if I crossed it out, there's probably a good reason. Okay, so since the massless energy orbit, which is perpendicular to the potential mass orbit of solid particles, or in the special case of light, when in superposition and from within the V realm, and since light has been reunitized when traveling through our space, it creates a wake, which we call the wave function. When waves are divided, it creates multiple pages or accesses that are divided within the V realm, a virtual realm. Don't get me wrong, the virtual, it's actually a superposition realm, which is very real. But I call it a V realm just because I have to name it something. These pages are stacked particle possibilities. Each page is a particle in a different space. Later on I talk about these pages as frames. And then it's convenient because it's frames of reference, basically. Different space within space alone. From its point of view, it is in the center, and its wake path is divided between several pages. From our point of view, since the v-space is at a different corpuscular time than here, it has a superposition time, and here is, in relation to that, our out of phase, and who knows how much slower or faster it seems our time must be an integer of v time, or buffer reality, or v realm. The tests to find out is pseudo light speed of a rotating of an interferometer pattern. The other test is an Elitzur-Vaderman bomb tester. If you switch the detector Vaidman on and off really fast, will there be a frequency that won't care? Can we sync the test where it won't notice the